Hello students, in this video we will discuss about fuzzy sets from third module. These are the outlines, classical sets and fuzzy sets. Let us see what is meant by a classical sets. This is also known as crisp sets, and we have already studied that a set is defined as a collection of objects which share certain characteristics. A classical set or a crisp set is defined as a collection of distinct objects. Each individual entity in a set is called a member or an element in the set. That means every entity in a particular set is called as the member of the set or an element in the set. Classical set is defined as the whole set split into two groups. That means classical set we can consider it as a two groups. That means if an element is a member of that classical set or not a member of the classical set. That means either an element will be a member of the classical set or it will not be a member of the classical set. That means no partial membership exists. Now let us discuss about the operations on classical set. First one is A union B. We have two sets A and B with certain number of elements, and the operation union gives a set uh, which contains elements that belong to A as well as to B. Next operation is intersection. A intersection B means it will return a set which consists of elements that are present in A as well as in B. That means the element in the set A intersection B must be included individually in the set A as well as in the set B. Next is complement. A complement equal to set X such that X belonging to capital X and X not belonging to A. That means we have a set A and it has some certain number of elements. When we are writing A complement, that particular set should contain elements which are not present in A as well as that are present in the universal set, which is represented using X. Next operation is difference, which is represented as A minus B. In this particular set A minus B, it will contain element X which belonging to A and does not belonging to B. Similarly, if it is B minus A, this particular set will contain element X which does not belong to A and belongs to B. Next is properties on classical set. First property is commutativity, which means A union B is same as B union A and A intersection B equal to B intersection A. Next is associativity. Suppose we have three sets, associativity implies A union B union C is similar to A union B then union C. Also, for intersection, A intersection B intersection C equal to A intersection B intersection C. Third one is distributivity. Here we will use two operations, union and intersection. So let us see distributivity. A union B intersection C is distributed. This union is distributed to this particular pair. So it will be A union B intersection A union C. Similarly, A intersection B union C equal to A intersection B union A intersection C. Next is idempotency. That means A union A equal to A and A intersection A equal to A. Next property is transitivity, which states that if A is a subset of B and B is a subset of C, then we can say A is a subset of C. Next is identity. where A union phi, phi is the null set which does not contain any elements. So A union phi equal to A and A intersection phi equal to phi. Also A union X. X is the universal set. Since the operation is union, it will return X and A intersection X equal to A. Involution means A complement the whole complement which will return A itself. Next is law of exclusive middle, that is A union A complement equal to X. Next property is law of contradiction, that means A intersection A complement equal to phi. De Morgan's law, which states that A intersection B the whole complement equal to A complement union B complement and A union B the whole complement equal to A complement intersection B complement. These are the properties on classical sets. Now let us see function mapping of classical set. Mapping is defined as a rule which states the correspondence between the set theoretic form and function theoretic form. In the case of a classical set, it is represented by a characteristic function psi of x, where this particular x is the element in the universe. So if we are taking the operation A union B, it will return the maximum element of set A and set B, which is the maximum element from set A and set B, that will be returned as the answer. And in the case of intersection, it will take the minimum value. And if it is complement, it will take 1 minus psi A of x. And containment means if A is a subset of B, then psi A of x is less than or equal to psi B of x. Now let us discuss about the fuzzy set. Fuzzy set is viewed as an extension and generalization of the basic concepts of the classical set. Whereas in the case of a classical set, partial membership is not allowed. But in the case of a fuzzy set, it allows partial membership. And it also has a degree of membership between 0 and 1. But in the case of a classical set, it was either an element will be present in the set or it will not be present in the set. So it have only two values, 0 and 1. But in the case of a fuzzy set, it has a degree of membership which ranges between 0 and 1. Also, member of a fuzzy set can also be a member of other fuzzy sets in the same universe. Here, a distribution, that is possibility distribution, is defined. A fuzzy set A in the universe of disclosure U can be defined as a set of ordered pairs. So let us see how can we define a fuzzy set A. This is the fuzzy set and it is defined as an ordered pair. The pairs are x comma mu A of x, where x is an element which belongs to the universe set and mu A of x is the degree of membership of x in set A, and mu of x can have values between 0 and 1, which also includes 0 and 1. When the universal set is discrete and finite, fuzzy set A is defined as defined using this following equation: mu A of x1 by x1 plus mu A of x2 by x2 plus etc. So that it is the summation of I equal to 1 to n mu A of xi divided by xi. But when u is a continuous and finite, fuzzy set A is defined as the integral of mu A of x divided by x. And this fuzzy set can also be called as a universal fuzzy set if and only if the values of membership function is 1 for all members of that set. Suppose we have a set A and the membership value or the membership function of all members is 1, then that fuzzy set is called as universal fuzzy set, mu u of x equal to 1. This is also known as Hall fuzzy set. And when we can say that two fuzzy sets are equal, suppose we have two fuzzy sets A and B and it is said to be equal if for all the elements, for all x belonging to the universal set, if mu A of x equal to mu B of x. And a fuzzy set A is an empty fuzzy set if and only if the values of membership function is 0 for all the members. A fuzzy set is called an empty set if all the members have a value of membership 0. That is mu phi of x equal to 0. Thank you.